Our topic is talking about the concept of photoelectric effect and demonstration. This lecture divides into two videos. Part 1 is talking about the concept on the photoelectric effect, while part 2 is performing experiment using our available photoelectric effect in this university. Now, in 18th century, Maxwell and other physicists says that light is a wave. And the interference and diffraction and polarization demonstrates the wave property of light. This says that the energy of light depends on intensity. But in 1905, Albert Einstein says that light is a particle. And this light is composed of photons. And these photons will carry an energy. According to Einstein, that when a light shines into the metal, the light with enough energy can eject electrons. So therefore, these electrons provides a kinetic energy. And this kinetic energy is the result of the energy of the light. But before the electrons will escape from the surface, the light absorbed first to the metal, then with enough energy of the light, then electrons will be liberated from it. And this electron is called as the photoelectrons. This is the concept of photoelectric effect. Now, the purpose of this lecture is to discuss the concept of the photoelectric effect in the part 1. In the part 2 is the demonstration of the concept. Einstein says that the light is composed of photons, and these photons are massless particle but with a discrete energy. The photons forms a wave packets, and these wave packets carries a discrete energy. Each photon has the energy, and that photon will strike to the surface to absorb some energy to the metal. Now, the application of the photoelectric effect is the digital camera, the night vision camera, and the solar panel. Then there are a lot of applications. So therefore, now, why is it that electrons ejected from the surface? In the surface, we understand that we have the positive ions and we have the electrons. And these two charges interact each other, and it holds a force. Meaning that these electrons was being exerted by a force due to the surrounding charges. So for every particle, there is a force on it. Now, since the electron has a smaller mass compared to the positive ions, then these electrons will escape from the surface if this force was being absorbed by some energy. And this energy that holds the electrons in place of the metal is called as the work function. In symbol, this is P. So therefore, if you wish to liberate these electrons, you need to overcome this work function. And this is talking about the energy that holds to the electrons, individual electrons. So therefore, when the light strikes to the surface, according to Einstein, that all lights has the discrete energy, which means that Each particle of light carries an energy in the amount of the Planck's constant. So, the Planck's constant multiplied by the frequency of light is the energy of photons. So, if this energy of photons will absorb to the surface to remove the electrons in the surface. So if this energy is enough, then so if it happens that the energy of photon is less than the work function, then the electrons cannot escape from the surface. Usually, the red light has a low energy. So for the red light to strike the surface, then it won't eject the electrons from it. Now, if it happens that the light has the energy of photon, which is exactly the same as the work function, so therefore it removes all the forces that holds on the electrons. Now, one photon, one electron will strike to the one electron. One photon, one electron. Now, in this case, the energy of the photon is just enough to remove the forces from the electrons. So, what will happen is the electron is free but cannot escape. Therefore, there is no velocity. So, it is just stays on the surface without forces acting on it, but it won't liberate. It won't move or escape from the surface. So, the requirement in order to have the escape velocity, then the photon energy should be greater than the work function. So if this is greater compared to the work function, there is an excess energy. The excess energy will be the energy of the electrons while escaping from the surface of the metal. So therefore, if you subtract the energy of photon by the work function, the result is the maximum kinetic energy of the electrons. Maximum is because that when it released from the surface, that kinetic energy is the maximum. As it travels through the space, it will slow down because of the interaction of the outside forces, external forces, then it will stop somewhere on the space. So the final velocity is zero and the initial is the maximum. And that maximum kinetic energy is the difference of the photon electrons and the work function. So with that energy, excess of energy, which is the kinetic energy, maximum kinetic energy, we can equate that to the formula of the kinetic energy, which is 1/2 mv squared. So therefore, we can always solve for the velocity or how fast is the velocity escape from the surface, because we have the mass of the electrons and this Kmax is the kinetic maximum energy. So in order to liberate electrons from the surface, energy of photons or EP should absorb on the metal surface to from release from the electric potential energy experienced by the surrounding positive ions called work function, and one photon releases one electron. It is a 1-to-1. Now therefore the energy of the light depends on frequency. The greater the frequency, the greater the energy. The red light has a frequency of 4.3 times 10 raised to 10 with a wavelength of 760 to 647. All red color light has a frequency of 4.3 times 10 raised to 14. Then followed by the orange with an increasing amount of frequency. Red and yellow almost the same, and the yellow has a greater, then going to green, blue, and we have the violet color, which has the highest frequency. So the violet, when when strikes to the surface, it provides a greater amount of kinetic energy of the liberated electrons from the surface. Now the analogy of the metal or the electrons on a metal to escape is just like a man on a wheel and a person on the top of the wheel. Man on the wheel asks for help, then if the man outside the wheel has enough energy, then he was able to rescue the man on the wheel. So what he need is he need something to pull it up. But if the energy is just enough to pull the man, then it follows that maybe he can escape or not, depending on the amount of force applied. So it is just like an electrons on the wheel. In order to escape the electrons from the wheel, we need some energy. And the energy is the energy of light. So if your energy is just enough to overcome this is the work function. The height, the depth of the wheel is the work function. This corresponds the energy requirement in order to escape the electrons away. So in that case, if the energy of photons is just enough, it will just stay on the level, but it won't escape. So because this energy is just enough, or the photon energy is just enough to overcome the work function. But if your photon energy is greater than the work function, so therefore if you shine a light to electrons, it will escape from the well. So therefore, the requirement in order to escape electrons is a light that has enough energy. So therefore, we can always calculate the kinetic energy because the difference between the two, energy of photons and the work function, is the maximum kinetic energy, which is equivalent to 1/2 mv squared. And we can calculate we call this as the quantum finite potential wheel. So the application of the quantum finite wheel is actually the photo cell, the solar panel. So when the sun strikes to the surface to the panel, then it requires energy before moving the electrons and forming current, so that current will be utilized for some consumption, energy consumption. Now, how to verify the photoelectric effect? How sure we are that there must an electron ejected from the surface? So this setup is the setup that verifies the existence of the photoelectric effect. This curved surface is a metal, and this is the cathode part. Cathode means the negative potential. While on the opposite side, we have this anode, and this is positive terminal. So this one was connected to the source with a DC source. This is the negative connected to the cathode, and the positive was connected to the anode. And we have the galvanoscope at this point in order to change the supply voltage, increasing and decreasing of supply voltage. This is the source voltage. So this voltage source will introduce a charge to the two terminal, the positive terminal and the negative terminal. Cathode for negative, anode for positive. So therefore, there are excess electrons on the surface, but it won't escape. It's just stay on the surface. Now what will happen if we shine the surface using the light? When the light strikes to the surface, then the tendency is it releases, if this light is enough, has enough energy, then these electrons will travel. Now since this is curved, the direction of the electrons will follow to the center of the curve. So therefore, the electrons, escape electrons will be attracted, because this is negatively charged and this is positively charged, will be attracted towards the anode. All released electrons will travel towards the electrons. So therefore, using the galvanoscope, we can verify the existence of the photoelectric effect. Because if there is current using the current meter or the voltmeter, whenever there is whenever there is current detected on the galvanoscope, then therefore there must be an electrons that travels on it. So therefore, this setup demonstrate the existence of the photoelectric effect by absorption. So the question is, how much kinetic energy being released or released from the surface? How much escape energy? Previously, we understand that the light provides the energy of the photons, then absorbed to the metal to overcome the work function P, and the difference is the kinetic energy. So how much is the kinetic energy? So therefore, in order to answer that question, we need to reverse the polarity, which means that we will change the position of the cathode. Cathode will be placed here and the anode will be. So the only way to do it is to reverse the source, which means that this one will become positive and this one is negative. So the current, okay, in this case current will flow. So therefore reverse the polarity. This is now the positive. This is now reverse power supply, positive, while this side is negative, attached to the anode. So therefore, this is more on or less electrons, and this is now more on electrons at this point. So when the light strikes to the surface, the electrons ejected will move towards the cathode. But if that energy is not enough, okay, the electron escapes, but remember that electron is a negatively charged, while cathode is also a negatively charged. So therefore, the tendency is to reverse its direction because they will repel each other. So therefore, the question is, can we find the maximum velocity or the kinetic energy from the surface? The answer is no. So the only way to solve the problem of the maximum kinetic energy is make sure that these electrons will move exactly at that point, which means that we need to adjust the galvanoscope in such that the electrons will move towards the cathode, but at that time the electrons will stop in moving. So therefore, still there is no current. So what kind of energy that will requires the electrons to stop at the cathode. That energy or that voltage, we call that as the stopping voltage. So we will adjust the galvanoscope in such that when the light strikes to the ground, to the surface, then it is enough to travel the electrons exactly at that point of the cathode. Then it will rest on that surface. Then the voltage is called as the stopping voltage. Stopping voltage because there is no current measured, and all electrons will stay on the surface of the or the point of the cathode. So, what's the use of the stopping potential? This stopping potential plays an important role of the existence of the photoelectric effect. So, why we reverse the power supply in order to come up with a zero current and all the electrons stayed on the cathode at rest. So take note that energy of photon, and we have the work done function. So if this kinetic energy is zero at this point, in the initial point, the kinetic energy is maximum. So therefore, there must be a work done on the electrons. And the work done by the electron is a change in kinetic energy. So what is change in kinetic energy? It should be final minus initial. So it should be 0 minus Kmax. Now, work done, this is the work done by the charge. And work done by the charge is the product of the electron particle charge multiplied by the stopping voltage or stopping potential. So this is stopping potential multiplied by the electron charge. The result is the work done by the electrons. So work done is a change in kinetic energy, while work done is negative. Why negative? Because this is a negatively charged electron. So the stopping potential is the voltage that that the amount of voltage that let the electrons to stay on the cathode. We call it as stopping potential. So multiplying that to the charge of electron, it is equal to the final. The final is zero, while the initial is maximum. So final minus initial. So we come up with negative negative. So therefore, the result is a positive. The maximum kinetic energy at the surface is equivalent to the product of the electron charge multiplied by the stopping potential. So, in other words, if we know how much is the stopping potential, what is the voltage reading on the galvanoscope, multiply it with the electron, the answer is the maximum kinetic energy. And this is the escape energy. So, if you wish to calculate how much is the velocity, then substitute this with the definition of kinetic energy, which is 1/2 mv squared. So, going back at the equation, now take note the difference of the energy of photon by the work function is the maximum kinetic energy. So therefore, there are two ways to solve for the maximum kinetic energy. Whether to multiply the potential stopping potential by the electron charge, or subtract the photon energy by the work function. By the way, the work function of some metals that exist are available on the references books. So, which means that work function can be found. These are constant to a material that have to a surface that have the same material. So therefore, given is the work function, but we don't know how much is the photon energy, and we can calculate the maximum kinetic energy because this is electron times V. So substituting the definition of maximum kinetic energy at this equation, replacing the photon energy. The photon energy is hf, means the Planck constant times the frequency of light. The frequency of light are available, depends upon the light, whether a violet light, blue. So which means that frequency are always available. So therefore, replace this to this equation, then this is known. So replace everything. So we come up with E V naught, where V naught is the potential energy, is equivalent to HF minus, or the Planck constant times frequency minus the stopping potential. So if we wish to form an equation that the stopping potential as a function of frequency, we will divide this by E. So dividing by E, this says that the stopping potential is equivalent to H over E, or the Planck constant divided E, multiplied by the frequency of light minus the work function divided by E. So this relation is a kind of linear relation. V naught, or the stopping potential as a function of frequency, which means that if the light has greater frequency, it requires greater potential, stopping potential. So therefore, remember that V naught are measurable, and frequency are also measurable, and this one is given on the material. So therefore, by experiment, you can verify you can compute the H value, which is the Planck constant, then compare that with a constant. So if that experiment, if the result is very close to the Planck constant, then therefore it is true that electrons escape from the surface. And the concept of photoelectric effect when tested. Okay? So the question now is, how much is the frequency, minimum frequency, to liberate the electrons from the surface? How much minimum frequency? So therefore, all you need to do is, if you wish to know how much is the minimum, so this voltage should be 0. The maximum kinetic energy should be 0. So if this is 0, now remember that H over E is the slope, while the work function divided by E is the y-intercept. So again, this is a linear relationship. So therefore, if this is 0, if we equate the potential B equal to 0, meaning, let us say there is no energy from the surface to escape, then we come up with this equation, equating this to 0. So we have H over E F, which is now the frequency cut off, minus the work function divide E. So therefore, we can cancel the E, and we can solve for the frequency of cut off, and we call this as the minimum frequency that requires the electrons to escape from the surface. Okay, so if you want to know how much is the cutoff, then you have to divide the work function of the metal by the Planck's constant. So, for a copper, we have the work function of the copper divided by the Planck constant. Then, for other materials, have other work function. Then, every materials, we can always find the minimum frequency of light. Uh, Observing the experiment, we will perform the experiment to verify the existence of the photoelectric effect. See you in the next video.